Hello everyone. Thank you very much for the given feedbacks about the first video. So in that video, we discussed about what we can do and what we can do with the threads, and what are the process based and what are the thread based differences. Also, what are the ways we can create threads and what are the advantages and disadvantages over each other. Yes, we just began the journey. So more to go and more to come. So let's go with the second video. In this video, I'm going to show you practically how you can implement the thread, and also what are the key hidden points with the threads. Also, most famous and most possible questions from the threads. So let's go with the practical example. So here I just created the project just to make sure we don't waste the time, right? So I'm going to create my class like we discussed last time. It's a printer class, right? So just let me to create a package for this, right? So com.create.thread. Okay, so I'm going to put this class into here. So right now, cool. So this printer class extends thread class, right? So this printer class extends thread class. Here, the first thing, right? It must to override the run method, right? Let's see what's going to happen if we did not override the run method. Okay, so we can get a clear understanding what is the run method and the start method and the relationship between those two, right? So I'm going to create the application class here, and in that application class I have a main method, right? So in the main method I'm going to call printer equal new printer dot start, right? So you can see it doesn't give any error for me, right? But now I'm going to execute this. Execute it, no problem, right? But nothing happened. So after this, I'm going to add a system out here saying this is from main thread, right? So now I'm going to execute this again. Right, it printed, right? So you can see here it's printed. So the point here, you can call the start method and it is not must to override the run method, right? So if someone asks, is it must to override the run method in the your thread implementation class? No, it is not if you're going to extend. But what happened here, this is how it works. When you go to thread class, right, thread class has the run method, right? So when you what happened here, when you call the start method here, is a printer dot start, it go and see, hey, do I have a start method in the printer class? No, I don't have. So then what is next? So then I go to parent class, thread class. Do I have a start method in the thread class, right? So if you go to thread class, yes, you do have a start method in this class, right? So let's search for start. Right, so you have the start method in the thread class, right? So in the start method, within the start method, they invoke run method, right? So when you invoke a run method, it go and see, do I have a run method here in the printer class? No, no one given me a run method. So then what it does is, it has a run method inside the thread class as well, but it is just a it's nothing, it doesn't do anything, right? So you can see it just if there is a if the target is set, it's trying to execute the target.run method. So in this case, it's just an empty method. It doesn't do anything to you. So that's why it's working. So scenario number one, it is not must to override the run method if you extend the thread class, but if you not override the run method, you are not doing anything, because last time we learned whatever the job thread has to do has to go into the run method. So if you don't have a run method, there won't be any job, right? This scenario valid if you extend the thread class, right? But if you implement the runnable interface, right? So if you implement runnable interface, right? So you can see it is like forcing us to override the run method, right? Because that is the behavior of the implementation, right? Interface. If you have a if you're implementing any interface, you must override all the methods within the interface, so it has in the interface. So if someone asks, can we stay without overriding a run method when you implement the multiple thread? Answer is yes, but condition to the scenarios, it must be come from the extend thread class, not the implementation. And if you not override the run method, then there won't be any job for that thread, and so nothing will happen, right? So now I'm go back to my extend scenario, right? So extend thread class. Okay, so now this time I'm going to override, right? So here I'm going to do something. This is from child thread, right? So now what I did is, now I did here, in the main thread supposed to print this is from main thread, and the child thread supposed to print this is from a child thread, right? So let's see executing this code, right? As you can see, from main thread, from child thread, but this not necessarily to be like this always. Let's do a little small experiment, right? So what I'm going to do here, okay, before we go there, so you can see here what happens is, from the application class we call printer.start method, but we clearly see printer class don't have a start method. So when the printer class don't have a start method, what it does is it go to its superclass. That's a standard double OP and standard inheritance practice, right? So when it go to the parent class is a thread. So when you go to the parent class has the start method, right? So parent class has the start method. So now in the start methods, it's calling run method, right? So when it called to the run method, it check, do I have a run method in the printer class, right? Yes, I do have, so it's going to execute it. So in this scenario, we have two threads, right? Child thread is created and created and executing its job, because there is a job be given in the run method, right? So if you see here, right, so it do something before it go for a run method, right? So because you can see here, right, this is the boundary, okay? So you can see here, it check the thread status and it add to a group, right? You have a comments, you can go and always read these comments and try to understand, right? And finally it started to it said to started true, right? So now there is nothing directly invoke run method within this start method, okay? So I'll come to that part, why there is no direct run invocation here, then where the exactly invocation happen, right? But we have a run method here, right? So now we have a run method. So in the run method, it asking to execute the target.run method, right? So now go and see what is the target. Target is a runnable object, right? So target type is a runnable. So that means our printer class, right? So whatever we created in printer class. So now it's executing run method of the printer class, right? So when we have a run method on the printer class, it's execute. When we don't have a run method in the printer class, it's again the normal way. It go to the its super class and execute the run method within this class because it doesn't do anything for you. All right. So now that covered first scenario. Now the second one, we haven't seen a run method over there. Then why it is that? So let's do something here. For int I equal 0, right? So and I less than, let's say, 10. Right. So now my child thread supposed to print 1 to 10 and concat with the child. Okay. So now what I'm going to do is I'm going to do same thing here, right? Instead of just printing the main, right? So what I'm going to do, other for loop here. Right. So my main thread supposed to print main and up to 100. Now this is interesting scenario. Okay. See how this work. Okay. So if you pay your attention on this console window, see how it work, right? So you can see it's child main, child main, child main, and then obviously it go the rest of the main because main has when it's trying to print to up to 100, right? So now the thing is, see here child main, child main, child main, child main, 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 child, right? So now this time you will see child main, child main, child main, like that, right? So again if you execute, you can see child, 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 then main, right? You can see here each execution has its different orders, right? So that's bring us to the other point. When you, I just mentioned this in the last video, right? So if you, whenever you start the thread, there is no guarantee it will spawn out instantly, right? There is no such rule. Then what happening here? So there is something called thread scheduler, right? So you start the thread, what it does is, if it is fulfilling all those things, it will add your thread into a thread scheduler, right? So how the thread scheduler works is entirely depends on your JRA. End of the day, it's a JVM because JVM is a specification, JRA is implementation, right? So it's depend on the JVM to JVM, right? So that means if it is working like this in a this machine, there is no guarantee it will work on a let's say in a Windows machine in the same way, right? In a Linux machine in the same way. There may be, but there may not be too. So the rule is the when you start a thread, there is no guarantee which order it will execute, right? So that's why if you see here, if you go back to our previous case, right? So when you invoke a start method, right? So it go to this start, right? You can see here group dot add this, right? So you can see these comments. So it tells you notify the group that there's about to start a thread, right? So then that thread scheduler will design which thread will go. Maybe first in first out, right? Maybe round robin, maybe some other different algorithm, which personally I don't know because I'm not master of each and every JRAs. But what I can tell you is there is no guarantee for that order, right? So that gave us the second point, right? So you can start thread, but there is no way you can guarantee how order it will execute. Now, next point, why we have to call the start method? This is also the famous question. What happens without calling a start method if you directly invoke run method? Okay, let's do. Here, instead of doing a start, I'm going to directly call the run method, right? I'm going to directly call the run method. So before I do that, right? So let me do something different, right? So still it will be the start. Here I'm going to concat. Here I'm going to concat right? You get the thread name also, right? So before it print, it's supposed to get the thread name. Right. Okay. So now let's see how this works, right? So I'm going to execute this. So you can see here now child thread get a ID called thread 0 and the main thread get saying main, right? So I'm going to execute again. Execute again. It's the same scenario. So to get it a little more clear, so I can get a space over here, right? So now you can see child thread has a name child, right? Oh, sorry, thread 0 and the main thread has a name called main. So now you can see this time main thread executed first even before child thread get executed, which prove our previous theory. So now this is how it's working, right? So what I'm going to do here, now I'm going to call the run method without invoking the start method, and let's execute again. So you can see, right? So is now thread name is a main, always main. Now thread name is always main. See, first is main and is also main. And also you can see other behavior. It always execute child before it execute the main. See, it always execute child before it execute the main. Now, this mean do we have a two threads? No, we only have a one thread, right? We only have a one thread. So what really happening here, when you invoke a run method, you are not giving an opportunity to create a new thread. So as a result, what happened is it just execute the normal method call. Let's say you execute some method like a cal or print or do something. So this run method will behave like that. So that means we are not creating a thread here. So if someone asks, can we invoke a run method directly in a multi-threading scenario? Yes, you can invoke, nothing is stopping you, but it will not create a new thread. It will execute from the parent thread. So then why it is forcing us to call for start method? What's the reason? The reason is like this. It is to make your life easy, right? So before it start the thread, it has to do many things. It has to see whether this thread is already exists, whether this thread is ready to run. So and it need to register on the registers and add into thread pools and so, right? So you don't have to do any of these things, right? So JVM take care of doing everything when you call the start method. When you invoke the start method, what it does is it do all necessary things and it invokes the run method. If there is no start method, it's just a simple pattern, right? So you know the design pattern and coding pattern. This is a simple way. If you need to do any utility things, what you usually do is you put that method into your parent class, and the parent class invoke child method, right? So then when you implement the child method on your child class, so it is getting invoked. So this is we follow all the time in the day to day when you do with the double OP programming, right? So now we learn other thing. We can invoke the run method, then it is not a multi-threading scenario. So then this other thing, because these questions we ask all the time in interviews, and all the time candidates are failing to answer, right? So that's why I'm bringing all these points, because these are points which is hidden inside these thread scenarios. Okay, so other thing. So now what I'm going to do is I'm going to override start method here, right? So public void start, right? And I'm going to put something, this is start, right? Just to make sure whether I did the right method, I just put the override annotation. If you didn't use the right signature from your parent class, it will give you error. Okay, so now we don't have error, so that means we override the correct thing, right? So now again, as usual, I'm going to call the start method. See what happened here. Okay. So now I executed this. You can see here, this is start. It printed it first, right? So it printed this is start first. Then main, it always main. Still we don't see new thread being created, right? So let's run again. No. Again. No. You can run again and again and again and again and a million times, but the result won't change. What we did here, we just simply violated simple double OP principle. So now, print a class called start method, right? So what it usually do is, it always give the chance to immediate class, right? So now, does print a class has a start method? Yes, it do have. So it go and execute that one. So you blocked a bean opportunity to create a new thread. Why? Because you are blocking is to invoke thread class start method. So now it won't create a new thread, it won't add to the registry, it won't do anything, so it won't work. So other thing, if someone asks, can you override the start method on your thread class? Yes, you can do, nothing stopping you. This is the same thing, right? So when I ask, can we override the main can we overload the main method? People say, no, you can't overload main method. The real answer is you can overload the main method. But JVM always consider public static void main string array argument signature, right? That's it. You can always overload the main method. So likewise, can I override the start method in your thread class? Yes, you can, but you will block calling. You will block creating a thread, right? So now, the next question: can I override the start method and still let to create the thread? Simple, right? So what I'm going to do is, here I'm going to do super dot start, right? Super dot start. Then this will do the job, but then it give you other question, right? So what is the order of printing? What is the order? Can we guarantee it? Here's the thing, right? So this is how it works, right? So in especially in interviews or an exam, right? So we ask question, right? So your answer will lead to other question, that answer will lead to other question, that answer will lead to other question. You solve enough problem, then the person will realize, yeah, he know concept in detail, right? So that's the difference between half baked and the full baked cake, right? So if you're half baked, there's no use, right? There is a waste, you can't eat, and it will throw away. So but don't be a half baked engineers or half baked programmers, right? So you have to understand the concept and the theory in detail up to the ground level. So now, okay, so execute again. Now you will see it created my new thread, right? Because I call the super dot start leading me to create the thread. So now this time it says this is a start main child. Okay, so run again, right? So now you can see child first, then this is a start. Why is this? What we do exactly here, right? So printer.start, it comes here and it calls super.start. When you call the super.start, it go to parent class, which is the thread class start method, and it will create a thread and add to the pool. This time, immediately that thread start to execute, right? So that's why you got this child printed. Then obviously you have a two thread this scenario, right? You have a main thread in the flow and the child thread, so both are executing parallelly, right? So this scenario, then other question, what happen if you put this is a start before the super dot start? Can you do it? Yes, you can do it, but see what happen. Sorry, see what happen when you run this. So now it says this is a start. Now when you say this is a start, now it says this is start, right? So why this is so tricky, right? When I ask this, 99.9 times people says no, you can't do that. Then I ask why? Because super has to be the first line of the method. Yes, super has to be the first line of a method if you're invoking super constructor, but not for the super class method. Okay, so with all those examples, I think now you have a really good understanding about the run method, start method, and how those work internally, and what is the use of those, why we have a start method, why we can't directly call the run method, what happen if you call the run method, what happen if you override the start method. So let me to do one more thing. What happen if you overload the run method? Let's say you can do something like this. I'm going to get the same method, then just give int x, right? So now we have a scenario where you have overload the run method, right? You have overload the run method. So now what will happen, right? So let's execute our program. Right, so nothing different, right? So there is no problem. So if someone asks, can you overload the run method? Yes, you can overload the run method, but thread start class, right? When you invoke the start method, so thread class start method will always invoke run method with the no arguments, right? So you always can overload the run method, but always thread class will execute run method with no arguments, right? So other method you can invoke your own way through your program, right? That doesn't matter. Okay, so one more thing to discuss, the question I asked last time, right? So how about if the main thread do more job than the child thread? So let's do something like this. So now in this case this is valid, right? So run method printing sorry, child supposed to print 100 and main thread supposed to print 10. So that means child thread has more jobs. So what I'm going to do is, when the main thread done its job, I'm going to print something like this, right? So now we know when the main thread done its job, right? So execute this program again. So you will see, no matter main thread, so this time main thread like was super fast, super slow. Right, so you can see here, right? So main thread executed first before the child thread, right? But still, even though main thread done its job, it's allow child thread to execute, right? So you can see it's a mix up now here, and the main thread done its job, but still child thread completed its job. So if you had an understanding, when the main thread terminate, your Java program terminate. No, it is not. That's a wrong understanding. Not only you, right? So most of people has this misunderstanding. When the main thread exit the program, when main thread leave the main method and it's done, it's the Java program will terminate. No, main thread may finish its job, but child thread, in the default behavior, child thread can continue its work, right? So now I'm going to do small modification to see, right? So you can execute this multiple time, just want to make sure, right? So always child thread go up to 99, right? See, it's 99. So now what I'm going to do here, I'm going to this has nothing to do with this overloading, right? So I'm going to remove this, and if you doubt, I'm going to run again just to keep you sure, right? So it's go up to 99, right? So if you doubt, just because the main thread in, okay, now in the perfect scenario, right? So now what I'm going to do here, before start the thread, I'm going to set printer dot set daemon equal true. So now I'm going to say, hey, you are a daemon thread, right? So we are going to learn what is a daemon and non-daemon, right? So you are a daemon thread now. So now I execute this again, right? So now you can see main thread ended and child thread ended in 35, right? So again you run 30, again you run 24. That means if the child thread is a daemon thread, when the main threads end its work, program is terminate. Then you will ask follow-up question from me in a comment or somewhere. Before you ask that, I will give you answer. Why then it go up to 24, right? Ideally, just after this the line it should terminate the program, but that's never happened. It's always go up to some value. So the reason is we're printing it here, right? How this system out works is a stream, right? So in a thread you just say, hey, print this, print this, print this, print this, then there is other process it take and print into your console, right? So the moment your thread is end, right, so it already processed up to 33 this time, right? That's why this number is vary, right? So this time it somehow it went up to 99, and this time up to 81. So it this time at 26. So it depends always. So what happens here, this delay you see because of this printing, right? It take time to print. So whenever you terminate the main thread, by that time child thread already processed up to 26, but it's asked, hey, print this, but the printing printing mechanism is not printed those yet. So that's why you will see this number here. But theory is, when your child thread is a daemon thread, right, the program won't wait. Program will not wait until your thread complete your job, right? In case if you want program to wait to until complete your job, then your thread should be non-daemon thread. So it prove our theory again. Program always terminate when the last non-daemon thread terminate. You can do this experiment, right? So you can spawn out two threads, right? So one is a daemon thread, one is a non-daemon thread. So give more tasks to non-daemon thread, then you will see main thread will finish its job, but still program will not terminate because you created non-daemon thread, right? If you want to keep the program running, you have to keep running at least one non-daemon thread. Okay, I think it's time to conclude the today video, right? So I promise I'm coming soon and within a few days or 1 or 2 days, because I want to keep go with this, because if I do one video in this week, another video in 2 other weeks, that's not going to happen because you will forget of what you will learn. So I'm going to keep going. Share this video as much as possible, people who you think interest. If you have audience, people you think this will be interest, so then share these videos, and subscribe to my YouTube channel, and also like my Facebook pages and follow me on Instagram. So stay in touch. See you soon with more little detail about the threads in coming up days. See you again.